All right. In our last chapter, we had a table that allowed us to change from Fahrenheit to Celsius or vice versa. We did not use the formula, which is right here. This tells us the Celsius temperature is equal to the Fahrenheit temperature minus 32 times 5/9. That's how you do it. All right? And if we use the formula and we have 47 degrees Fahrenheit, 47 degrees Fahrenheit goes right there where the F is, right? So this is my formula here, so let me highlight that. This is the formula that changes to Celsius. This is what I would use. And this is the same. I've simply replaced my F with the value of Fahrenheit temperature. So that's what's happened there. So the book itself, this is a copy directly out of the book. They said this is the formula. They went ahead and substituted 47. So basically we need to evaluate this expression. Okay? There is a little bit of order of operations happening here. Specifically, order of operations, parentheses happens first. So before I do any multiplication of 5/9, I have to subtract 47 minus 32. Notice the signs are different. So now this is a subtraction problem before it's a multiplication. So we go back to day 1 and day 2. The signs are different, so should I add or subtract? Subtract, so 47 minus 32 is 15. Is it positive or negative? Positive because 47 is bigger. So subtract because the signs are different, positive because 47 is bigger. So go back to what Kevin said before. Bigger, smaller has to do with addition and subtraction rules for sign. Multiplication, division rules, same sign, positive, different signs, negative. Have them separate in your brain. All right? So 47 minus 32 equals 15. That's being multiplied by 5/9. 15 is positive, 5/9 is positive. 5/9 is a fraction, and since I have a fraction in my problem, I'd probably put 15 over 1 to make 2 fractions in my problem. I prefer fractions for everything if they're fractions or anything. Again, I look for a possibility of reducing fractions. Before I multiply, if I can, something on top, something on bottom with a common factor. 5 and 9 both divide by 3. So 15 divided by 3 is 5. 9 divided by 3 is 3. Now nothing else reduces. Top times top, 5 times 5 is 25. Bottom times bottom, 3 times 1 is 3. So what's the Celsius equivalent? Now, here's a situation where I'd probably get a decimal approximation, because when you're asked to tell a temperature, you don't usually say 25/3, right? What's the temperature outside today? 25/3, right? It's kind of weird, right? So, if I do 3 into 25, maybe use a calculator, you're going to get 8.3 repeating. All right? That's a more appropriate value for temperature. And typically, if somebody's telling you the temperature, they use a whole number, right? So if this is me telling you 47 degrees Fahrenheit is approximately 8 degrees Celsius. Round to the nearest whole number if you're dealing with temperature. So the formula is going to get you decimals quite often because that 5/9 has to be a pretty friendly number to make the 9 go away. So more often than not, changing to Celsius, you're going to get decimals more often than not. So get a decimal answer and round to the nearest whole number. That's the most appropriate final answer for temperature.